would like to be a scientist.
Our project is electricity, conductors, and insulators.
And in SABES, we're engineers too, so we made stuff.
It's an excellent program because it implements the math curriculum, and it just ties in everyday problems and problem solving.
This event is a STEM recognition event. It's being held by an organization called SABES, which stands for STEM Achievement in Baltimore Elementary Schools. SABES is a partnership between Johns Hopkins University and the Baltimore City Public Schools, and it's funded by the National Science Foundation. And the purpose of this project is to engage with 3 particular communities within Baltimore City and work with them both during the school day and after school, and with the community as a whole in order to raise the profile of STEM within the community and instill STEM as a value.
I think science is very important to children that go to urban schools because I don't think that in general we get enough exposure to science in the regular classroom environment.
Our project is electricity, conductors, and insulators. And circuits. We created different types of circuits like simple circuits, series circuits, and parallel circuits. And with different items, we tried to let electricity flow through different items. And if the electricity can flow through an item, that means it's a conductor. And if electricity cannot flow through an item, that makes it an insulator. If we get a wire, and then you get your light bulb and put both of the ends to the light bulb, and it will light up.
So the general layout of the event is that this entry hall we're standing in now is where students are going to show off their projects to their parents or caregivers or friends and family who come, and also to other students from the different schools. So you'll see there are poster boards set up where students are showing off the sort of things that they've made. So we think it inspires students by giving the opportunity to do things that are hands-on, so they get to build things themselves, see how they work, improve them, test them, and really engage one-on-one with the activities. But beyond that, we're trying to pilot something that we call student-driven projects. So the purpose there is to allow students the opportunity to go into their own neighborhood and say, what's going on in my neighborhood? Where does science and engineering fit in my neighborhood? And what are projects I could work on where I'm deploying science or engineering to deal with the problems that I think are relevant?
My project is magnets and how to build a vacuum cleaner. Connect the wire to the paper clips. And when you wrap both of these on there, you will pick up some paper clips with the tip of the nail.
As a parent, I believe this is a good program because it keeps kids motivated and involved in their learning, and it, creates in them a want, or I guess a need, to learn. So they're motivated to, to participate in class and that kind of thing.
So the outcome we're really hoping for today is that the students come to the Science Center, get to experience the Science Center, but get to show off what it is that they've been doing all year long. So they get to explain to other students, to their parents, to their teachers, about different aspects of science and engineering that they got to engage with and express their enthusiasm for it, because I think it's by doing that, by being the one explaining, that they get to feel some facility with science and engineering themselves, and they can see themselves as the expert.
We want to accomplish to see how much a vacuum can suck up from outside by the trash that's on the ground. Me and my friends, we started to do a project because we were collecting trash. And we did so much trash that we tried to build a vacuum and see what we had to collect while we were outside.
It definitely introduces the curriculum to the kids, and it also reinforces what they've already learned. It just is a great motivation booster. The kids are able to showcase what they've learned, showcase what they know. They're able to see what other students are working on, and they're able to carry it over into the following grades because they're hands-on activities, they're very engaging. The information just sticks with the children.
The program itself targets specifically grades 3, 4, and 5. And we think that those grades are really critical because it's when students are really forming their idea of what they're interested in as a life interest or a career, and trying to understand how are the subjects they're studying in school relevant to their own lives. And so we think it's really important that science, engineering, and math get engaged in that way in that grade cohort. And then also there'll be places where students and parents together can work on little design projects, building things, improving them, seeing how they can make something that spins in the wind to generate electricity, seeing how they can build little aerodynamic things.
So we're gonna have to build something now. The trick is you can't tape it to the book and you can't tape it to the table.
We're engaging a whole lot of different populations. For example, some of our schools have large populations for whom English is a second language.
Science is, I like it because we do experiments, and I like to do experiments. We engineer and we do stuff like, in third grade we did guitars and instruments and all of those stuff.
Le deseo todo lo mejor que sea posible, en todo lo que yo pudiera desearle, lo que yo no tuve, quisiera que él lo tuviera. Todo siempre lo mejor para él. I think he's doing great. Yep, perfectly. Always has science, always. Yep, I'm very proud. Yep. Sí, todo. Es la prioridad perfecta para mí.
So the parents are obviously instrumental in preparing the students and enrolling them in the after-school program to begin with. But then this event is particularly important because it's an opportunity for the students to show off for their parents and family members what they've been doing, explain why they're interested in it and how it's important, and maybe for parents to have bragging rights a bit to what their students have been doing during the day, both in the classroom and outside the classroom. And we think it's really that sort of interaction where students get to show what they're doing to their parents and explain its value, and parents getting to explain that then to their friends and neighbors that will hopefully raise interest in STEM within the communities.
A fossil was a living thing that died in a natural source of water and was preserved over millions of years. And I will share some tips for you to become a paleontologist. A paleontologist is a person who studies fossils. A paleontologist uses a brush to dig softly, because if you smooth it out too hard, it might break. And like this fossil is a cockle shell, because you can see it right here. It made me feel excited when I started doing experiments.
It's been a fantastic experience seeing the kids play with cars, think about what does it take to make a car go, and see the first inklings of interest that could eventually germinate into a lifelong interest in science and engineering. So I find it's hard to think of something more worthwhile.